This is going to be 4.6 exponential and log equations. So we've talked about logs and exponentials extensively. We looked at the graphs. We looked about converting exponentials to logs and logs to exponentials. And then we were able to use some of the log properties. So now what we really want to do is solve these equations, and then later on we'll do some word problems where you can see where logs and exponentials are used in real life. So the first thing that we're going to talk about is exponential equations. So usually when you solve exponential equations, here are basically some of the steps that you want to be able to do. The first thing is you want to be able to isolate the exponential expression. Exponential expression. And usually what these guys look like, they look like this. So you can see e to the x. You might be able to see 2 to the x minus 1, e to the 0.7t. These are exponentials, 3 to the power of 4x plus 1. So these are what we call exponential expressions. So they're going to be as an equation, and you want to be able to isolate that part. Okay. The next thing that you want to be able to do is take a log. Take a log to both sides. Okay. And what you want to do, not just take any log, but with the appropriate base. Okay, with the appropriate base. Okay, so basically, when you want to take the log to both sides, if you have a 2 to the x minus 1, then basically the log that you're going to take is log base 2. Because what's going to happen is that if you have the log of the same thing, then that's just going to give me 1. So basically everything cancels out. So by doing so, it'll get rid of that part, and you'll just have that left over. So if you have log base a of a to the x, then all you just have is x. So that's basically the idea behind these problems. And then what you want to be able to do is just solve. Okay, solve. Be aware that because we know exponential equations kind of look like this, it doesn't matter if it's exponential growth or decay. The exponential models kind of look like this. So you can see that this guy is never negative. So never negative. Okay, at least if it looks like that. Okay, so you want to make sure that when you're doing these types of problems, if it equals a negative number, you should kind of like be like, could this happen? And you will be able to know once you plug it into your calculator, okay? Because the logarithm doesn't like negative stuff. Okay, so we're going to go ahead and just start doing a couple of examples so that you guys can get a little bit of a glimpse of what this looks like. So we want to solve and give exact and approximate answers. And I'm going to say let's say 3 decimals. Okay, so let's say we had something like that. And then we want to start off easy. So 2 to the x equals 7. Okay, so let's say we want to do something like that, because sometimes there's going to be problems that you can't quite do. If it was like, for example, 2 to the x equals 4, we can immediately figure out what that is, because you just have to think about what should I raise 2 to get a 4. Well, the answer should be x equals 2, because 2 squared gives me 4. If I did 2 to the x equals 8, then the answer in this case will be 3, because 2 to the 3rd power gives me 8. However, what can I raise x to so that I can get a 7? Now you're not quite sure what that is, but we know that the answer should be between 2 and 3, somewhere in between there, because these answers are 4 and 8. 7 is between 4 and 8, so your x value should be between 2 and 3. Okay, so now what we want to be able to do is let's go ahead and solve for the value of x. So the first thing that we want to do is isolate the exponential equation. The exponential equation is already solved for, so that one's good. So now what you want to be able to do is let's apply a log. So we're going to apply a log base 2 to both sides to get rid of that 2. So you're going to have 2 to the x here, and then you're going to have 7 here. So basically what's going to happen is that this guy is going to go away, and you're left with this x. Another way that you can think about it is that x comes to the front, and log base 2 of 2 is just 1. So you're left with an x by itself. So x is equal to log base 2 of 7. This is what we call the exact answer because it's not rounded, okay? The exact answer will be this. So usually on WebAssign, I'm pretty sure the majority of the problems want exact answers. Okay, now if you want to go ahead and figure out what exactly that is, go to your calculator and you should see the button that says it's right before the second. So it says ln and log. And what you want to do is press 3 times. So if you have the TI-36, this is for the people that have the TI-36X Pro, just press that button 3 times. So if you press it 3 times, you're going to see that it gives you log base of something. On the base, put a 2, and on the argument in the parentheses, just put a 7. And it's going to give you an approximate answer. So it's going to be 2.807. So this guy is what we call the approximate answer. Okay, so if you want to know exactly what a log base 2 of 7 is, then that's what it's going to be. If you have a different calculator, just go ahead and hit me up, and I'll go ahead and show you how to do it in that calculator. Because the TI-36X Pro is more fancier, like I said in the very beginning, this is going to save you a lot of time. If you want to know what the approximate answer of this guy is, you have to do some other stuff like change of base formula. One way that you can do it, if you have a different type of calculator, you can always just take the natural log of this guy, which is 7, and then divide it by the natural log of the bottom part, which is going to be 2. Because most of you guys will have that. And if you put ln of 7 and then divide it by ln of 2, you'll see that you're going to get the same thing, 2.807. So even if you don't have the log base button, you can always just convert this to a natural log, put a 7 on the top and put the 2 on the bottom, and it'll give you the answer. Okay, so that's how you can kind of do it. So let's try another problem. Okay, oh, and we did know that it was between 2 and 3. It's 2.8. Okay, so let's say we want to do e to the 0.1t is equal to 4. So how would you solve something like this? Well, the first thing that we want to do is think of the natural log that will cancel out the e. So the log will be the natural log. Okay, and then we're just going to put e in here, 0.1t, then 4. So you'll see that this guy's going to go away, and you're left with the 0.1t by itself, and you're left with ln of 4. Okay, now let's solve for the value of t. So I'm going to divide by 0.1. So t is going to be equal to ln of 4 divided by 0.1. This is the exact answer, exact. If you want the approximation, put it in your calculator. ln of 4 divided by 0.1. That's going to give me about 13.863. That's the approximation. Okay, again, so make sure that you look at WebAssign. I'm pretty sure for the most parts, they want this guy. Okay, so if you get the wrong answer and you give them the decimal, it probably wants it in natural log form. So let's say we have 2e to the negative t plus 1 is equal to 7. So we need to isolate the exponential. So we need to isolate this guy. This guy is my exponential. So I need to isolate it. So let's move the 1 over. So you're going to have 2e to the negative t is equal to 6. Then we're going to get rid of the 2. So do not apply ln immediately because we need to get rid of that 2 first. So I'm going to divide by 2. So you're going to have e to the negative t is equal to 3. Right, now we can get rid of the natural log. So I'm sorry, of the e by applying a natural log. Okay, so that's going to give me e to the negative 3 in here, e to the negative 3t, and then a 3 on here. This will go away, so you're left with negative 3t is equal to ln of 3. And then just finally divide by negative 3. So t is equal to ln of 3 over negative 3. That is my exact answer. My approximation would be the ln of 3 divided by negative 3. That gives me a negative 0.366, rounded to 3 decimal places. Okay, so let's try another one. So let's say we wanted to do 2x is equal to negative 4. Okay, So what we want to do is let's apply a natural log because that's already given out. And you can kind of see there's a negative here. Oh, there should be a red flag in that case. So we're going to apply a log base 2 to both sides. And then you're going to have the 2 to the x here and a negative 4 over here. This goes away, so x is equal to log base 2 of negative 4. Now, if you press log base 2 of negative 4, what are you going to get? It's going to give me domain error, which basically means there is no solution. Okay, so there's no solution because this guy is exponential growth. That means that when you do this guy, there's no way that this guy is ever going to hit negative 4. Okay, so there's no way. Okay, so therefore this guy is no solution. Okay, let's do a couple more. Let's do 4 to the x minus 2 equals 7. And then we'll do a harder one. A, B, C, D, E, F. Then we'll do 3 to the x minus 2 is equal to 4 to the 2x plus 1. So let's say we have something that look like that. So the first thing that you want to do with this guy is let's apply a log to both sides. So I'm going to apply log base 4 because that one's already been isolated. And then in the inside, I'm going to leave it as is, 4x minus 2, and then a 7. So this is going to go away. I'm left with x minus 2 is equal to log base 4 of 7. Let's cover the 7. Now I'm going to add the 2 to the other side to solve for the x. So x is equal to 2 plus log base 4 of 7. Okay, this is the exact answer. Okay, do not add the 2 and the 7 because the 7 is inside the log, but it's being protected. Now, if you want to go ahead and find the approximation, it's going to be base 4 of 7. This is going to give me 3.404. That's the approximate answer. All right, now this one. Okay, now this one's a little bit more involved. Okay, so you have to be very careful. So first, let's go ahead and try to get rid of one of them. Now we can't get rid of both of them, but we can get rid of one. So why don't I get rid of the 3 first, for no reason at all. I'm going to apply a log base 3 to both sides. So this guy is going to be 3 to the x minus 2, and the other guy is going to be 4 to the 2x plus 1. Okay, so this is going to go away, so that's gone. X minus 2 is equal to, and you just have log base 3 of 4 to the 2x plus 1. This one doesn't cancel out because it's not a base 4. So now what we want to do is let's move this guy over by using properties of log. So you're going to have this 2x plus 1 here, and then you have log base 3 of 4, which is just a number, something that we can plug into the calculator. Okay, so now what we want to do is we want to get all the x's on one side. So remember, this is just a number. So let's just FOIL this out. So you're going to have x minus 2 is equal to 2x log 3 of 4 plus log base 3 of 4. Now let's put all the x's together. So I'm going to move this x over. So minus 2x log base 3 of 4 minus 2x log base 3 of 4. This goes away, so you're left with x minus 2x log base 3 of 4 minus 2 equals log base 3 of 4. Now, this is just a number. Remember, it's just a number. Here's a 2. Let me move the 2 over because that's also a number. So you have x minus 2x log base 3 of 4 is equal to 2 plus log base 3 of 4. Here what we can do is we can factor out an x. I'm going to take out an x. So all I'm left with is just a 1 minus 2 log base 3 of 4 is equal to 2 plus log base 3 of 4. And then finally, I can just divide both of them by this guy. So 1 minus 2 log base 3 of 4. So this goes away, and I'm left with x is equal to 2 plus log of 3 of 4 divided by 1 minus 2 log base 3 of 4. This is my exact answer. Okay, so that means this is all just a number. So if I put this in my calculator, what are you going to get? So 2 plus log base 3 of 4 divided by 1 minus 2 log base 3 of 4. And that's going to give me about negative 2.141. That will be my solution. Okay, so this one was much more involved because you had a lot of moving parts. Okay, now let's do one last one. So let's say we have something in quadratic type. So e to the 2x minus e to the x minus 6 equals 0. So notice that this guy looks a lot like x squared minus x minus 6 equals 0. And it actually is because it is a quadratic form. Okay, so what you want to do is let's factor this. So how do I get e squared? Basically e squared. Well, you just have to have e to the x and e to the x. Okay, that's going to give me e to the 2x. Okay, and how do I get a 6 and what two numbers multiply to get a negative 6 and add up to get a negative 1? That's going to be 3 and 2. And then this guy is going to be a negative. This guy is going to be a positive. And this is equal to 0. So now we're going to set both of them equal to 0. So e to the x minus 3 equal to 0. E to the x plus 2 is equal to 0. I'm going to add the 3 here. So you get e to the x equals 3. We're going to take the natural log to both sides. And then this will cancel out. So all I'm left with is x is equal to ln of 3. So this is basically the exact answer. This guy, e to the x equals negative 2. Oh, notice how you have a negative 2, so it's probably going to be no solution. So when I apply a natural log to both sides, x equals natural log of negative 2, this is going to be no solution. So this guy doesn't give me a solution at all. And if you want to figure out what ln of 3 is, the approximate answer, you just put ln of 3. That gives me 1.099. So this will be my solution. Okay, so quadratic equation comes back. Again, if your factoring is kind of off, you will have to use quadratic formula. But remember that you're doing quadratic formula on the e, not on the x.